Hello everyone, and this will be an introduction lesson for exponents and roots. Now, even though it's an introduction lesson, I'm assuming that you know a little bit about exponents and roots. So I'm going to go a little bit faster in this lesson because there are a lot to cover. But I think even though it's your first time seeing exponents and roots, this lesson should be fine. It's not going to go into too much depth, but we're just going to cover the basics. Okay, so let's start with exponents. Exponents are ways of shortening multiplication. So remember when we're adding numbers in arithmetic, so let's say we're adding 5 plus 5 plus 5 plus 5. Instead of writing the same thing 4 times like this, you can just simply write that as 4 times 5, right? And this means that 5 is being added 4 times. So once you memorize the multiplication table, you can just, instead of having to add these individually, you can just say that the answer is 20. And exponents do that for multiplication. So for example, if you're multiplying 5 4 times like this, you can shorten this expression using exponents. So the way you do that is 5 with a little 4 on the top. Okay, so this does not mean, let me actually write that here. This does not mean 5 times 4. Okay, this does not mean 5 times 4. So this does not equal 20. This means 5 times 5 times 5 times 5. Okay, and in this expression, the number down here, the big number down here, is called the base. And the little number up here is called the exponent. Or another name for that would be power. So when you read this expression here, you can say 5 to the 4th power, or 5 to the power of 4. Either one's fine. And again, this right here does not mean 5 times 4. This means we're multiplying 5 4 times. Okay, so please don't make that mistake. When students see something like this, 3 to the power of 2 or 3 squared, that's a special name for power of 2. Instead of saying power of 2, you say 3 squared. And then if you have, let's say, that expression, you say 4, instead of saying power of 3, you say 4 cubed. These are special names for power of 2 and power of 3. Okay, but anyways, when evaluating this expression, 3 squared, this does not equal 6. A lot of students put 6 for this. This does not equal 6. This means 3 times 3. Right? 3 is being multiplied 2 times, so that should give you the answer of 9. This should be the answer. And the same thing with 4 cubed. This does not equal 12, but this is saying 4 times 4 times 4, which is going to equal 64. Okay, so please be careful when evaluating exponents. It's very tempting to just multiply the exponent with the base, but don't multiply the exponent with the base. The only number that's being multiplied is the base, and the exponent just tells you how many times the base is being multiplied. Okay, so that's what you need to know for exponents. Let's move on to roots. And you can think of roots as the opposite of exponents. So for example, we evaluated previously that 3 squared equals 9. If you take the root of 9, or more specifically square root, because this is squared, we're taking the square root of 9, you should get back 3. Okay, that's the number that you've started here. 4 squared equals 16. So when you take the square root of 16, you should get back 4. Okay, so the square root is the opposite of exponents. And there are other roots besides square roots. For example, 2 to the power of 3, or 2 cubed, equals, that's 2 times 2 times 2, which equals 8. And you can take the cube root of 8 to get 2. So now this is called a cube root. And as you can see, there's a number 3 here. When there's no number, like in our first two cases, it means it's a square root. It's the opposite of squares. And for higher roots, or for roots with higher numbers, they're going to have some kind of number in here. And this number is called the index. So for our third question here, the index equals 3 here. For our first two questions, we don't see the index, which means that the index equals 2. Okay, so this is like the default value of the index. When you don't see any index, or when you don't see any number in between there, it means that the index is 2. Okay, so cube roots are the opposite of cubes. So the 3 cubed equals 3 times 3 times 3, which equals 27. That means that the cube root of 27 is going to equal 3. So it's easy to evaluate roots, like square roots or cube roots, if you're familiar with the squares and cubes and other exponents. Now there are other roots as well, higher than cube roots. So 2 to the 4th power, that's 2 times 2 times 2 times 2, which is 16. And you can take the 4th root of 16 to get back to 2. Okay, so the 4th root is the opposite of the 4th power. Notice you can also take the square root of 16. You don't write the index for square root. Square root of 16. Right? And please don't say 8 for the square root of 16. You can think, what number times itself gives you that number? And obviously that's 4. So because 4 squared equals 16. Right? So these are some of the basic roots and exponents. One last thing, or I guess one of the few last things that I want to cover here, is the case with the exponents and roots of 1. 1 to the 3rd power, what do you think that would be? That's 1 times 1 times 1, which equals 1, right? That does not equal 3. That's not 1 times 3. Similarly, 1 to the 7th power. It's just 1 times 1 times 1 times 1 times 1 times 1 times 1, which is going to equal 1. So any power of 1, because you're just multiplying 1 by itself every time, any power of 1 is going to equal 1. And similarly, any root of 1 is going to equal 1. So if you take the square root of 1, it's going to equal 1. If you take the fourth root of 1, that's going to equal 1. Because in a way, 1 to the fourth power also equals 1. Okay, so the 1 is a special number where if it's raised to any power, or if it's taken to any root, it's still going to equal 1. And another number that I want to cover is the number 10, because many students make the mistake with number 10. 10 squared, what does that evaluate to? That equals 10 times 10, right? Which equals 100. But many students make the mistake of writing 20 as 10 squared, which obviously is not true. And you would see a pattern for 10 as well. When 10 squared is 100, 10 cubed is 10 times 10 times 10. So that's 1000. 10 to the fourth power is going to equal 10,000. And you'll see the pattern that the number of zeros in the answer equals the exponent, right? So there are 2 zeros for 100, which correlates to the power of 2 that the 10's been raised. There are 3 zeros here for the power of 3. There are 4 zeros here for the power of 4. So using this pattern, you can straight away evaluate what is 10 to the power of 11. And that's just going to be 1 with 11 zeros. 6, 7, 8, 9, 10, 11. Right? So instead of having to multiply 10 11 times, if you recognize the pattern, then you can just straight away evaluate the power of that. And you can also do this backwards, like the square root of 100 will give you 10. The cube root of 1000, I'm running out of space here. The cube root of 1000 will give you 10. The fourth root of 10,000 will give you 10, etc. Okay, so these are the basics of exponents and roots.